Hello and welcome to today's lesson, which is on iteration. Okay, so before we start the process of iteration, it's worth noting some understanding of this using a graph. Now, the thing is, what we're doing usually is we're trying to solve equation using an iteration. So you see this one here says the root of equation x cubed minus 7x minus 12 is equal to 0. And it's that whole equal to 0 part which is really important. So the thing which is important is that when you are solving an equation, you're basically finding out when it's crossing the x-axis, okay? So if you've got some kind of axis like this, and you're solving it, you're finding out where it crosses the x-axis, okay? Now this is really important because you're crossing a particular value here, and you can use this information to help you. If you notice that kind of a little bit left of the solution, which is this black dot here, you actually end up being below the x-axis, and this is a negative value, okay? And slightly above, so if you go right this time instead of left and go this way, and I go up, you notice that this is actually above the x-axis and it's a positive value, okay? So this is above the x-axis, which means that it's positive. Over here it could be 1, it could be 2. And this one here is below the x-axis, which means that it's a negative value. So this could be -1, it could be -2. And there's loads of examples of this. I've actually got a few little examples over here if I have a look at one of these graphs. So here, I'll make it big for you so you can see it. So with this one here, we've got a Desmos graph, and it's y is equal to x squared plus x minus 2. So if I look at this graph here, like so, and I'm going to zoom in a little bit here on this graph. So we can see in this graph here that we've got a solution of 1. There is another solution as well, but you notice that there's my solution of 1, and a little bit below this graph is a negative value. So that there says negative 0.28, and the further you go down, the more negative it's going to get, so that's minus 1.1 now. So below the graph is negative, okay? And if I go above the graph, you see it starts to become positive, so 0.29, and if I go further up, 0.8, and the further I go up, the more positive it's going to be. So before the solution, we have a negative value, then we have our solution, and then after the solution, we have a positive value. And this is really, really important. This is basically the starting point of iteration. And this is kind of where we're going to go with our first one. And they do ask questions like this. So let's have a look now at this first question. Okay, I'm going to keep this up here just as a little hint for us. But this first question here, I'll make it big so you can see it. Now they don't usually ask it as explicit as this. Usually you have to be able to do this yourself. But in these here, I've left it up. So this is 2 marks. Okay, let's make this nice and big so you can see it. The graph of x cubed minus 7x minus 12 is shown below. The root of the equation is x cubed minus 7x minus 12, which is equal to 0. Show that 3 is less than p is less than 4. So it's saying that p is the root, okay? So you notice you've got your graph on here, so this is our graph, and we're saying that p here is your root, so that one there, okay? So, to prove that p is a root, you look at something which is just before p, in this case 3. You look at something which is just after p, in this case 4. And if you sub both of those values in and you get one negative value and one positive value, then you know that it's just below and just above the curve. So p must be somewhere in between it, which means that there must be a solution between 3 and 4. Now that's tricky to understand. Okay, I'll show you how to do this one then. So with this one here, we've got our equation, which is, so this one here is example 1. I'd probably get this in your notes. Make sure you're getting all of it in. I'd even get the graph in your notes as well. So here we've got y is equal to x cubed minus 7x minus 12. So the first thing we're going to do here is we're going to substitute in 3 to see where the solution for 3 is. So when so x is equal to 3. Now if I'm substituting into that, I'm replacing all of this with 3. So it's going to be y is equal to 3 cubed minus 7x, minus 7 times by 3 minus 12. And I'm going to sub that in and work that out. So let's get that into our calculator. So bracket 3, bracket all cubed, minus 7 times by 3, minus 12 is minus 6. So this one here is equal to negative 6 there. Okay. So the next one I'm going to sub in is x is equal to 4. So here y is equal to bracket 4, remember we're subbing into this, 4 cubed minus 7 times by 4 minus 12. So let's sub all that in. Now you can, if you want, just go back and replace the 3 with the 4. That's what I'm going to do. So go back on that, replace the 3 with the 4. I'll show you that so you can see it. Brilliant. Press equals, and that's equal to 24 there, like so. Now, why is this really important? Why do we have to do this? Well, you notice that when x is 3, we have a negative value, so it's below the x-axis. When x is 4, it's a positive value, so it's above the x-axis here, like so, which means that somewhere in between there, between it being negative and between it being positive, it must be 0. So it must be crossing that x-axis to have a solution. And that's what we need to be saying here. That's what we need to be really clear. So when x is equal to 3, we have it equal to minus 6. When x is equal to 4, we have it equal to 24. So it says there is, so this is the key part here, and this is what we need to make sure we're writing. There is a sign change. This is the important part. There is a sign change. I'm going to put stars next to that so you know it's important. Therefore, P is between 3 and 4. And it's this idea of that sign change which is really, really important, okay? So because we have that sign change, because it's below the x-axis and then above the x-axis, it means there's a sign change, which means that it must be going through the x-axis, so there must be a solution. Okay, that was the first one, okay? So let's have a go at some of these together then. So look, notice sign change. It's all about that sign change, okay? That's what the answer is. So let's have a look at this one then. So this is usually part A of the question, okay? So usually part A is show that there's a root between blah, blah, blah and blah, blah, blah. I've got some more examples here for us to have a look at. So let's have a look at this one. I'll make it big for you so you can see it. So here's a table, y is equal to x cubed minus 6x minus 5. So it's actually giving you the table of values giving you the table of values already. Between which two consecutive integers is there a solution? So the idea here is that what are we looking for? We're looking for that sign change. That's what's really important. We're looking for that sign change. So if I go across here my table, where does that sign change occur? Well, that sign change occurs between minus 9 and 4. So minus 9 and then it goes to 4. So where must my value lie? Well, it must be between 2 and 3. So that's what I'd write here. So this one here is example 2, but it's just an idea of kind of pushing this idea of the sign change. So example 2, there is a sign change, that's the important part, between x equals 2 and x equals 3. So therefore, this is the 3 dots there means therefore. Therefore, there is a solution between 2 and 3. Now this is really important. We can go back to this graph here if we want. So looking at this, So because we have minus 9 down here and plus 4 up here, it means that there's a sign change, which means it must be, this line, if it's connected, must pass. If it's below the x-axis and then above the x-axis, it must be passing through 0, which means there must be a solution. Brilliant. So I'm going to suggest that you pause now and have a little go at that one on the right. I think you should be able to do it yourself. So pause now and have a little go at that one on the right. Okay, so I'm going to show you how to do this one. It's very similar to that first one, to be honest. I just put it up there just to cement this idea. So show that the equation x cubed plus 7x minus 5 has a solution between 0 and 1. Remember, we're looking for that sign change. Okay, so first of all, when x is equal to 0, we need to sub in this value here. So we're subbing into x cubed plus 7x minus 5. So let's sub that in. It's going to be 0 cubed plus 7 times by 0 minus 5, which is going to be equal to, you can do it on your calculator, but that's equal to minus 5. 0 plus 0 minus 5 is minus 5. So then the next one, when x is equal to 1, that's going to be equal to 1 cubed plus 7 times by 1 minus 5. So we can sub that in our calculator. I could work that in my head. 1 cubed plus 7 is 8. Take away 5 is equal to 3. Again, notice that this one is negative and this one is positive. But we need to really state that there is a sign change between x equals 0 and x equals 1. So there is a solution between 0 and 1. So because we've got that sign change, there must be a solution in between it. Now, let's have a look at the main part of iteration. Now, iteration itself, let's just check those answers actually, sorry. Brilliant, sign change, 2 and 3, super. Cool. So, let's just cut back. Now, the word iteration means to repeat and repeat a pattern, also to put something back in, so repeating. What we're actually doing with iteration is you're using the answer that you've got to find out the next sequence in the pattern, okay? So you're using the previous term to find out the next term in the pattern, okay? So this here helps you to generate the pattern. Now, let's have a go at this example here. So this is example 4. Okay. Now, that first part is part A. This would probably be maybe either part B or part C. Sometimes they ask you to rearrange to get to this stage. So this could be a part C. I'm not going to do the rearranging part today. Because I will do that in a different video. But today we're just going to look at the iteration process of actually doing the iteration part. So this is the rule that it gives you. X of n plus 1 is equal to 2x of n plus 7. And it says that x of 0 is equal to minus 1. Now, this here, it doesn't look like anything you've usually seen before. It doesn't come up very often in GCSE like this. But what this means is, now this is the bit that people find a little bit tricky. You notice this is x of n, and this is x of n plus 1. Now the way we think about this is just like sequences, okay? So x of n is one term, x of n plus 1 is the next term. X of n plus 2 would be the term after that. But because it's just a generic term, it's just saying that the previous term, that's what this means here, the next term, this one, x of n plus 1, like I said, the next term, is equal to 2 times by the previous term plus 7. Okay, that's what all of this means. My next term is equal to 2 times by my previous term plus 7. Now, with iteration, they always give you a starting point. And in this case, they've given it you as x0. So they've said that my starting point, my first term, is equal to -1. Okay? And then you're asked to work out the next terms in the sequence. So, this one here, I'm going to write down my first term, my starting term, which is this one. So to work out my next term, which is this one, it's 2 times by my previous term plus 7. Okay. Now the way you write this, if this one here is x of 0, my next term is going to be x of 1. Okay. Now x of 1 is equal to 2 times by my previous term, which is -1, plus 7. Okay. So it's my 2 times by my previous term plus 7. So in this case, it's 2 times by -1 plus 7, which is equal to 5. So this here is x of 1. Okay? Now if I want to work out x of 2, again, now I'm changing here because I've just worked out that this is now a different term. My previous term isn't -1 anymore. For x of 2, my previous term is 5. So for this one, it's going to be 2 times by 5 plus 7. So 2 times by my previous term plus 7. So 2 times by 5 plus 7 is equal to 17 in this case. So x of 2 is 17. And then to work out x of 3, it's equal to 2 times by my previous term, which in this case is 17, plus 7. So 2 times by my previous term. So 2 times by 17 plus 7, which in this case is equal to 41. So then I've worked out those 3 terms. Okay, they always give you a starting term. And then remember, this x of n and x of n plus 1 means that it's my previous term to work out my next term. Okay, that's what's really important with this one. So pause now and have a little go at that one on the right hand side. I will go through it in a sec if you're still struggling with this. But if you're ready, pause now and have a little go at that one on the right. Okay, so let's have a look at this one together. Now, this one here gives us the iteration formula, which is x of n plus 1 is equal to 3x of n plus 2. So what this one here is saying, my next term is equal to 3 times by my previous term plus 2. Okay, now it's giving us our first term. It will always give you the first term. In this case, it's equal to 2. So my first term is equal to 2. So let's now work out what each of those are. So if I start with x of 0, which I know is 2, my next term, x1, is equal to 3 times by my previous term, which in this case is 2, plus 2. Okay, so 3 times by 2 is 6, plus 2 is 8, so there you go, there's your first one. Next one, x of 2 is equal to 3 times by my previous term plus 2. Now my previous term is now changed. My previous term is now 8, so it's 3 times 8 plus 2. So 3 times by 8, 3, 16, 24, plus 2 is equal to 26. And the next one, x3, is 3 times by my previous term, which in this case is 26, plus 2. So 3 times by 26 plus 2 is equal to 80. Brilliant. Okay, so they always give you your first term, and then it's the previous 3 times by my previous term plus 2 is my next term. Okay, nice and straightforward. It's not that tricky. So let's just check those answers. So 5, 17, 41, 8, 26, and 80. Now, there is something that I haven't talked to you about yet, and that's about the ways you can find this quicker. Okay, the quicker way of doing this if you've got lots to find out. Okay, now with this one here, let me go back to this one actually before we start. Now, here, we actually subbed in each time, didn't we? We subbed in 5, then we subbed in 17, we subbed in -1, then we subbed in 5, then we subbed in 17 into each of these. But actually, if you want to do this iteration process loads of time, you want a quick way of doing this. Now, the way that we do this is by using this answer button on our calculator. See here, this answer button, okay? This answer button is the way that we do that, okay? Now, first of all, let's say if I was doing this one, using the method I'm about to use, the first thing I need to do is I need to store -1 in my calculator, okay? So here I write -1, -1, and I press equals. Now that stores it into the calculator, okay? So if I press answer now, answer will come up with -1. It's stored the answer as -1, okay? So then if I want the next value, I need to do 2 times by the answer, and in this case it was +7. Now the reason this is important is because every time it puts out an answer, it's already got it for you. So if I press now equals, it's going to do 2 times by -1 plus 7. So 2 times by -1 plus 7, we know is equal to 5. Brilliant. The thing is now, my answer has changed. My answer is 5. So if I press equals again, it's instead of doing 2 times -1 plus 7, it's doing 2 times my new answer, which is 5, plus 7. So if I press equals again, we know it should be 2 times by 5 now, plus 7, which is 17. So, bingo, 17. Brilliant. And again, my answer is now changed again, hasn't it? So my answer isn't 5 now, my answer is 17. So if I press equals again, it's going to do 2 times by 17 plus 7, which in this case is the 41 that I want. And we can use this technique by using that answer and storing it on our calculator to do it when we're doing it 5 or 6 or 7 or 8 or 9 times, or when you've got a horrible number. Sometimes this is a really nasty decimal, and in which case you just want to be able to get it in there and get it out. Okay, let's have a look at some more questions. So, let's move on from that. So here we go. This one here is a little bit nastier. So this one here is example 6. Example 6. So, starting with x of 0 is equal to 4. Use the iteration formula. X of n plus 1 is equal to the square root of 5x of n minus 1 4 times to find the solution to this one here. So x squared minus 5x plus 1 is equal to 0. And give your answer to 3 decimal places. Okay, so it's actually given us our first term. We always know this. My first term in this one, x0, is equal to 4. Now my iteration formula in this case is my next term is equal to the square root of 5 times by my previous term minus 1. Okay, so my next term is 5 times by my previous term minus 1. Now I'm going to do this, the new method, by using the answer button. So the first thing I'm going to do is store 4 in my calculator. Now I do that, in this case, by pressing AC, and let's press 4 there, and press equals. That's going to store it in my calculator. So I know that x0 is equal to 4, and it's stored in my calculator. If I want to work out x1, it's going to be the square root of 5 times by my previous term, which in this case I'm going to say, 5 times my previous term, which in this case I'm going to say is the answer, close bracket, minus 1. Now notice I've replaced this x of n with the answer because that's what I want to do. I want to repeat this pattern with the new value that I've just found out. Okay, so what this is basically doing is x of 1 is equal to the square root of 5 times the answer, which I know is my previous term, which is 4 minus 1. And you can work it out like this. If you prefer to work it out like this, I don't mind that. But if you want to do it quickly, then I will just use the answer button. So if I press equals now on that, remember that 4 is stored. Okay, so press equals, and I get root 19. Okay, now this is the problem. This one here is 4.358899. It's a big, long, nasty number. So if you want to put that back into there, it starts to become quite problematic. But because I've already got it stored, this answer here is now stored in my calculator. So all I have to do is press equals again once, and it will give me my next answer. So x2 is equal to 4.560098. If I want x3, I press equals again, and again it puts the answer back in there. So equals again is equal to 4.6690. It's going to be a tricky one, that one. 90. It's actually all going to round up. 100. And x of 4. So press it equals one more time, and I end up with there 4.72710. Now, this here says use the iteration formula 4 times to find an estimate to the solution, giving it to 3 decimal places. So my solution would be x is equal to 4.727 to 3 decimal places. Brilliant. Okay, so the way I did this, just to recap, is I used this answer button. Okay, so I stored 4 in my calculator, so by pressing 4 and then pressing equals, and that stores it in my calculator. And then using the iteration formula, which is the square root of 5 times by my answer, which in this case is 4, minus 1, and I press equals to get my first one, there. I press equals to get my second one, I press equals to get my third one, and I press equals to get my fourth one. Nice and straightforward, nice and quick. Okay, so I'm going to make this big. Pause now if you're feeling confident and have a little go at that one on the right hand side. So pause now and have a go at that one on the right. Okay, so I'm going to go through this one now. So this time my starting formula is my starting value is x0 is equal to 3. My iterative formula is x of n plus 1 is equal to the square root of 4 times by x of n minus 2, like so. So it's asking us to do this 3 times. So starting with this number, use the iteration formula 3 times to find an estimate for this solution. So I know that x of 0 is equal to 3. So the first thing I need to do in this is I need to store that in my calculator. And I do that by going 3, press AC first, so 3 equals, that's stored in my calculator. Make sure you press equals, you can't just type 3. Check it if you want, answer is 3, answer is 3, brilliant. So now I know that 3 is stored in my calculator. Then I'm going to use the iterative formula. Now I would probably show the examiner what you're doing here. So x of 1 is equal to 4 times by, and you could put answer in there if you want, because that's what it's going to be, 4 times my previous answer minus 2. If you wanted to, you could show the examiner exactly you know what you're doing. So 4 times by 3 minus 2. Okay? So here, the square root of 4 times by my answer minus 2. Okay? So 4 times by my previous term minus 2. So let's press equals to get my first one. In this case, it's root 10. So this is equal to root 10. Let's write it as I'll write it as root 10. Root 10. To get my next value, I press equals again. And if I press equals again, it puts root 10 in there now. So press equals again. So x2 is equal to 3.26328. And x of 3, I press equals again. So it's putting that one back into my formula again. Equals is going to be equal to 3.324634. Now it says do it 3 times, correct to 3 decimal places. So in which case, x is equal to 3.325 to 3 decimal places. Brilliant. Okay, let's just check both of those answers. 3.325, brilliant. 4.727, let's just check that. 727, yeah, perfect, brilliant. So we've got both of those answers. Okay, so I've got some trickier ones now. Only 2 more to have a little go at. If you want to, you can pause now and have a go at these yourself. I'll make them big so you can see them. So maybe pause if you want to and have a go at both of these if you're feeling confident. Okay, I'm going to go through this first one then. So this time it says that my starting value x0 is equal to 0. Okay, it's given us the iteration formula, so my next term, x of n plus 1, is equal to a half minus 3 times by my previous term, all over 2. My previous term cubed is that. Yeah. So use the estimate 3 times to find the solution for this. Okay, so I know that x of 0 is equal to 0. Brilliant. First thing I need to do with this is to store that in my calculator. So 0 equals. Okay, that's now stored. Let's check. Press 0 equals. Press answer. Is it 0? Yes, it is. Brilliant. So I'm then going to sub 0 into my next one. So x of 1, so my next term, is equal to a half minus 3 times by my previous term cubed, all divided by 2. Remember that when I'm doing this in my calculator, it's just using the answer button. So let's type that in. Let's make sure you can see this. So fraction button first. 1 over 2 minus fraction button 3 times by my answer, close bracket, this time cubed, 3 times by my answer cubed, so my previous term cubed, all divided by 2. Okay, so a half minus 3 times the answer cubed, all divided by 2. Press equals, it's going to be for my first value, which is a half. It says to do it 3 times, so x of 2, I'm just going to press equals again, and this time it's going to put the half in there for me. So in this case, x of 2 is equal to 5 over 16. X of 3, all I need to do is press equals again, and it'll put it back in for me again. In this case, it's equal to 3721 all over 8192. Now it does want to say it wants it to 3 decimal places, so I'm going to press S to D in that one so I can get it as a decimal, which is 0.454. Well, I can just leave it like that because it's only to 3 decimal places, but I will say that x is equal to 0.4532 decimal places. Brilliant. Super. So I started off with my first term, which is 0. I used the iteration formula, which is a half minus 3 times by my previous term cubed divided by 2. Remember, this is equal to our answer. Button. Brilliant. So, again, I'm going to say pause now and have a little go at that one on the right-hand side. So pause now and have a little go at that one on the right. I'm going to go through it now anyway. So starting with x0 equal to minus 1. So in this case, x0 is equal to minus 1. My first term is equal to minus 1. So x of n plus 1, my iteration formula, is equal to the cube root of 2 times by my previous term minus 5 all over 4. So this is my first term. So I need to store that in my calculator, and I'm going to do that by typing minus 1 into my calculator and pressing equals. Check that it's in there, press answer, equals, is it minus 1? Yes, it is. Super. So let's just make it really clear to the examiner, x of 0 is equal to minus 1. My first term is minus 1. So it says to do it 4 times now. So x of 1, now it's always worth writing, I think, out the first one, okay? So it's the cube root of 2 times by minus 1 minus 5 all over 4. Remember, I'm subbing in my previous term to find my next term, okay? But when I'm doing it on my calculator, I'm not subbing in minus 1, I'm subbing in answer because I know that that's minus 1 right now. So it's the cube root. So the cube root is just above, see this x with the square above it. So shift this one here, okay? And I need to do the cube root of, press the fraction button then, fraction button, 2 times by my answer, so which in this case is minus 1, minus 5 all over 4. Now it's quite tricky to type in your calculator that. The cube root of 2 times by the answer, minus 5 divided by 4, press equals, it'll give you my first term, which in this case is minus 1.205071. X of 2, so remember that to find x of 2, all I need to do is press equals again, and it will sub that value in for you. So minus 1.228166161. So it's subbed it in. Then I press equals again for it to sub in this value. Brilliant. So x of 3 is equal to minus 1.2307077, and x of 4, press equals again, minus 1.23098. Now it says it wants it to 2 decimal places, so in this case x is equal to minus 1.23 to 2 decimal places, like so. Brilliant. Super. So let's just check those answers. Minus 1.23 and 0.454. Brilliant. Now there is one more type of question for this which comes up, and sometimes they ask it as a population question, so it is worth noting that. It's very, very similar. It's only come up a handful of times on Edexcel, but it's exactly the same process as this. So I'm just going to show you now how this works. So I've put this graph up here. Now you might think to yourself, well, what has the first part that you showed us, which was crossing the x-axis between a negative and a positive, what's that got to do with this iteration process? How does doing this iteration process show me a particular value? Well, what happens when we do a iteration process is that we're basically splitting up the equation sometimes into a straight line and sometimes into a curve. Now your iterations here, what happens is, as you sub in your value, you notice this green line. So here my initial value was 0.1. So when I subbed it in, I got value which was 0.2. Okay, so follow my mouse here. When I sub that in, I get a value of about 0.5, let's say. When I sub that in, I get a value of just over 0.7. When I sub in 0.7 into this, I get a value of 0.6. And what happens is, you'll notice that you've got this kind of the spiral effect here. What happens is you end up spiraling in towards, the more times you put in a value into your iteration formula, the closer and closer you get to where these two lines cross, which is your solution to this. So, now this is a difficult concept. Before this was moved into the GCSE, the only time this ever came up was actually in year 13. Okay, I think the process of actually doing it is quite easy, and I think you should be able to do this. But understanding why it works is really tricky. Now, in this, the thing that you need to know is that the more times you do an iteration, the more times you sub it in or press equals on your calculator, the more times it kind of goes up and like this looks like a little bit like steps. So steps and then a cobweb in. So the more times you do this iterative process, the closer you get to the solution. Okay, so that's the reason for it, really. Now, as I said, that is a hard concept to understand. If you can do this, you are going to get the marks, but I just wanted to make it really clear why this works, okay? And it works because it's, as you can see, it creeps up to where these two values cross, so there, which is the solution of these when you split up an equation, okay? So, let's now have a look at some questions on this. So here's our questions. So pause now and have a little go at those questions. So pause now and have a go at those. Remember the two parts. We're looking for the sign change in those first few questions, and then we're using the iterative formula for the rest. Okay, so I'm going to pop the answers up. So mark these in green. Mark those in green. Brilliant. So thank you for watching this video on iteration. Do make sure you're having a go at these questions, because remember, the only way to learn maths is to do it. There are some difficult concepts there for you to understand. I think being able to actually do it is the easy part. Understanding why it works is quite tricky. But do make sure you're having a go at these. I think everybody should be able to do this section. So thank you for watching and have a lovely day.